Hello, good morning, everyone, and thank you for all attendees and all presenters who are here with us today. So today we will be having this overview of the True Connector, and so providing Gabriele de Luce and Igor Baloc are with us, and they will be providing some insights about the project and also the roadmap and how to deploy it. And this Tech Talk is powered by projects like PD4 Energy, Databricks, and Datamite, EnerShare, Omega X, Tango, Divine, and Dacapo. And we all know that a lot of projects and a lot of initiatives are already trying to deal with the True Connector. So fingers crossed that it will be a good opportunity for everyone who is with us today here. And I would like to invite Gabriele to the floor, and yeah, thank you.
Thank you, Anil, for the introduction. Let me share the screen. Could you see my screen? Yes, okay.
Yes.
So again, thank you, Anil, for the introduction, and thank you all for joining today. And thank you to IDSA for giving us the opportunity to present to you today some insights and an interesting hands-on session related to the True Connector. So I'm Gabriele de Luce from engineering, part of the Smart Industry and Agri-Food unit, and I'm a member of the Digitech Research and Innovation Laboratory. I'm here with my colleague Igor Baloc from Engineering Software Laboratory. So the topic of today is the True Connector. The agenda is split in two parts. We have an overview where we can see what is the True Connector, what are the main features, the architecture, the certification process that for us is quite important, and an overview regarding the status, the current status of the activities and the roadmap for the future. Then we have a very interesting part, hands-on session, where we are going to show you how the True Connector can be used in a minimum variable data space, how you can set up easily and run 2 instances of the True Connector, or in the second part, how you can use the True Connector in an hybrid data space. So how you can use the True Connector to interact with other connectors like the database connector. Then we have time for questions. I would invite you to ask every kind of questions using the chat, but we should have also time at the end of the webinar to use the microphone and to perform the questions orally. We are glad to answer you all. So let's start with the first part of the webinar. So what is the True Connector? So True Connector stands for Trusted Engineering Connector, is an open source IDS connector implementation designed and maintained by engineering. It is open source, released under GPL version 2 license. It means that everyone can contribute, and we are open for contribution. And the rationale, the project started in 2019 in the context and thanks to the Market 4.0 funded project. The rationale from the beginning was to create something simple, a base connector that address the base security profile, now trust level 1, lowering the barriers for the adoption and for adopting IDS in the real world. The True Connector is a Java application based on 2 main frameworks, Apache Camel and Spring Boot, for defining the message routes and the endpoints, for the communication endpoints. It is based on and support the IDS info model 4.1.text. is mandatory since we have to follow the IDS information model for representing the metadata information. We tested the integration with existing connectors I already mentioned, and this is also part of the hands-on session that we will have in the second part of the today webinar. But we tested officially the integration with existing solutions like the one coming from GEC and the Boost 4.0 project during the official integration camp events. We also performed the the integration with the data space connector. The true connector is composed mainly by two parts. The execution code container, that is the most important part in charge to the physical communication and interaction with the IDS infrastructural components. And a data app, we provide in the bundle the basic data app, that is the one, the application, the components that the only one that you have to customize in order to integrate your systems. And we have several extensions like the Fiber data app, since one thing that I missed, but really important, is that the true connector is also part of the Fiber catalog. I have a dedicated slide for it, and we'll see in detail how it works, how this extension works. The true connector is open to verticalization, and a tangible example has been realized in the context of the OneNet project, and you can find the OneNet connector in the data connector report. In that case, the Fiber extension has been improved, customized, and verticalized in order to satisfy project requirements. But the main keyword is that the true connector is easy to use and to customize. And we'll see now why. The true connector, I already said, is open source. Is multi-data format and multi-protocol, since starting on the 2019 and from the IDS reference architecture model 3.0, we had the opportunity to serve the IDS specification and to now we have the opportunity to give to the user the possibility to configure the true connector according to his needs. It means that the true connector is totally configurable, and you can choose the right combination between data formats and protocols that we currently support in order to satisfy your needs and to address your requirements. It's extendable, and this is thanks to the fact that from the beginning we follow with the IDS reference architecture model specification and the true connector. In the true connector, there is a strict separation, and we will see in detail during the architecture analysis. There is a strict separation between the execution code container in charge of the physical data exchange and the data apps, the components that the user has to customize for integrating the external systems. And is finally, we can say that the true connector is easily integrable, thanks to the fact that it is configurable, is a direct consequence, but also thanks to the fact that we are working to enlarge our interoperability metrics in order to be compliant with other solutions, connector solution, and also with the most common, especially the open source ones, IDS infrastructural components. This is the architecture in the large. So here I don't want to be exhaustive, but just to emphasize the main components that are part of the true connector. So basically three main components: the execution code container already mentioned, the data app already mentioned, and the usage control app, that is the one in charge to enforce the usage control, one of the main pillar of the data sovereignty. All components are Dockerized and are Kubernetes ready. It means that the true connector can scale easily. In the execution code container, you can see several subcomponents, and again, the list is not exhaustive, but also to demonstrate what are the subcomponents that are involved in relation to the role that the true connector is assuming. In this picture, you have two instances of the true connector. On the left side, you have the consumer, and on the right side, you have the provider. And you can see in the execution code container the subcomponents that are some way that will intervene, that will be active part of the data flow in relation to the role that you have in the data space. For example, on the consumer side, we have the interface with the data app for interacting with the data app. This is an internal interaction, private interaction. The interaction with the identity provider, since is the identity provider is necessary for implementing the access control, the physical data exchange, the interaction with the clearinghouse for registering transaction, and the enforcement of the usage control rules that the two counterparts have to exchange during the contract negotiation phase. On the right side, you have other examples, for example, the semantic validation, since when I receive data, I have to check if the data is compliant with the IDS information model, like I mentioned before, but also I have to perform, I have to check if the identity of the user interacting with the identity provider. In the picture, you can see that there is the possibility to extend the connector. For example, if you can customize a connector working on the data app, for example, customizing the basic data app I mentioned before, that is the one provided in the bundle, but also following the Lego approach, you can decide to create, why not, a pipeline of data apps in order to satisfy your needs. This really depends on your requirements and your real needs. Now, I don't want to consider the IDS role, like the architecture picture, but now I want to be focused on the physical data exchange. So again, you have two instances of the true connector. So you have the data app and the executable container. On the left side, you have the executable container that acting as a sender. But what happened? The executable container receives the message from the data app. So the data app is in charge to create, to start the interaction, to create a message, an IDS message, so compliant with the IDS information model. The executable container, as I said before, is responsible not only for the physical data exchange, but also for interacting with the existing with the IDS ecosystem, so with the infrastructural components. And in this case, for example, has to interact with the DAP server in order to attach the token to the original message for implementing the access control. Then the message will be sent to the receiver executable container, so to the receiver through connector, and the transaction will be registered to the clearinghouse in order to implement the non-repudiancy. On the receiver side, the message will be received, will be validated semantically, but also from the access control perspective, the token will be checked, verified. The message will be sent to the data app that is in charge to perform the request and satisfy the request received, prepare the response. The response will be sent back to the executable container that forward the message to the sender, registering the transaction to the clearinghouse also on its side. Finally, the message will be enforced by the usage control framework and forwarded by the final user. One important thing is that we currently support two usage control frameworks, one totally open source, integrated, and that we have the opportunity to integrate thanks to the strict collaboration with Tecnalia in the Platoon project, but also we can give the possibility to the user to use the Medidata framework powered by Fraunhofer. And this is the compatibility matrix I mentioned before. So why the True Connector is easy to use and easy to be integrated with existing solutions, since it's configurable and we support several data formats and several protocols. So it means that the user can decide to configure during the config time the True Connector for exchanging data using the multi-part mixed, multi-part form, or HTTP either ways. But also can decide to enable the communication through HTTP, HTTPS, WebSocket over HTTPS, and IDSCP version 2. And on the right side, we have the wide range of infrastructural components that we currently support, for especially the open source ones, but regarding the brokers, we support the metadata broker from Fraunhofer, the Intersoft broker, that is another interesting result that we achieved in the context of the Market 4.0 project, the mobility broker. It's an identity provider, the OMID, the ISEC version 2, Orbiter, that, by the way, we had the opportunity to validate during an official integration camp events, and quite new Atos Trust Center that we had the opportunity to integrate in the context of the Eureka project. And the clearinghouse powered by the open source clearinghouse powered by Fraunhofer. This is an overview regarding the validation scenarios that we had the opportunity to validate. So we have for the manufacturing domain, you know, I said before that the Market 4.0 is the father of the True Connector, and we had the opportunity to support the interaction and the communication between companies and the marketplace realized in the context of the project. In the Eureka project, we had the opportunity to enlarge our interoperability metrics, as I said before, but also we are collaborating with SQS in order to acting as a consumer for the 3D printing data space. I have a dedicated slide for it. In the circular theme project, we are interested to enlarge the interoperability metrics, adding new connectors like the trusted connector, like the Eclipse data space connector in our interoperability metrics. We have Da Capo and Claros that are two interesting projects where we want to enlarge the applications in terms of data apps and extensions that we can define and design the next month. In the energy domain, we have the very fruitful collaboration with Platoon and OneNet. With Platoon, as I said before, we had the opportunity inside Platoon, in the context of Platoon, we had the opportunity to add, to integrate the open source framework for the usage control. OneNet I already mentioned before, and the extension that you can find in the data connector report. We had the opportunity to validate the true connector in the aeronautic sector, in particular in collaboration with Avio Aereo. We realized a scenario that you can find in the data space radar, and that also was part of the launch coalition. I have a dedicated study also for it, so no further detail now. We are active part of the testbed, official IDS testbed. I mean that we validated the testbed, and we are totally compliant with the components that are part of the testbed, and we can be active part of the minimum valuable data space that everyone can put in place following the guidelines and the infrastructural components that are described in the testbed project. And for the agri-food domain, we have two interesting projects, C-Trace and Divines, that, by the way, has been also mentioned by Anil before. Now, let's go in details, analyzing three different validation scenarios in order to give you also the possibility to know how we use the True Connector and how the True Connector can be used in the real life, not only from the paper perspective. So for the aeronautic sector, I mentioned before, thanks to the collaboration with the Avio Aereo, the problem that we addressed, the request that we addressed was to enable the communication between three different establishments located in three different countries. So you can see on the right side the providers. In particular, one is located in Poland, the other one is located in Czech Republic, and we have the opportunity to configure and to install two instances of the True Connector in order to share some CSV files with the consumer that is located in Italy. Consumer users is represented here by the Avio Aereo engineering staff, and from the technical perspective, what we did is to customize the True Connector with another extension, customizing the data app in order to integrate our solution, the True Connector, with the digital enabler suite powered by engineering, for giving to the Avio Aereo engineering staff the possibility to consume data using all applications that we have implemented in our suite. Another interesting use case is the one related to Fireware. I said before, True Connector is part of the Fireware catalog, and in particular, part of the Fireware catalog is the Fireware extension. It means dedicated Fireware data app. You can see in the picture, and just ILD data app, since the Fireware data app is implementing the NGSILD API. So we are working with the standard, and thanks to the Fireware True Connector, two existing Fireware ecosystems are able to communicate under the data sovereignty principles in a plug-and-play way. It means that no code is required, but everyone can just download, read the documentation, download the Fireware True Connector, customize a few things. For example, where is the context broker on its site, and be a player of a data space with Fireware on the two sides. And the last validation scenario that I'm going to present today and to share with you today is the one that we are realizing in the context of the Eureka project, in particular in integrating or consuming data coming from the 3D printing data space. Here in the picture, you can see the testbed realized the data space put in place by SQS in the context of the Eureka project. And here we had the opportunity to integrate the new Altos certification authority I mentioned before, and also we had the opportunity to consume 3D model data that we getting and receiving the file and printing the object on our premise, as you can see from the time-lapse video that we included in the slide. Very interesting scenario and very interesting validation for us. Now let's continuing with the certification process. You know, it's very important for us, the certification, obtain the certification, and it's important for everyone who want to be a player of the data space. And starting from the criteria catalog, components connector, the white paper defined by IDSA, we started the process officially, and in the next weeks we will complete the certification, and you can see on the left side the 3 chapters that are part of this of the catalog. So we have more or less 90 or 94, if I'm not wrong, criteria divided in 3 different chapters: idea specification, ISO 62443, that is the ISO for cybersecurity manufacturing related criteria, and development criteria. You can see the percentage that we already covered, and yeah, we are in contact with SQS, that is our evaluation facilities, to proceed with the missing ones and to proceed with the certification process in order to accomplish it. And this is our roadmap, our Kanban. I would say that it's not exhaustive, but just to emphasize some main work streams that are related to our what we complete, what we are doing, and what we plan to do in the next weeks. So as I said before, thanks to the synergy with the Platinum project, we complete the integration with the usage control totally open source that is you can find in the True Connector bundle. We are working on the integration of the improvement of the extension of the integration metrics. As we just added the Atos certification authority, but also we are interested to enlarge the connectors. The connectors, for example, I mentioned before, the trusted connector, the DC connector, in order to enlarge the compliance with it, but also with new infrastructural components. We are refining the validation scenario I showed you before regarding Eureka, since we are solving some issues, the communication issues that we met during the communication between the True Connector and the data space connector acting as a provider. And we, as I said before, we are working on the certification, on the satisfaction of the criteria that are part of the certification process. Regarding what we plan to do in the next weeks is to design a graphical user interface way to configure the connector in order to simplify the life of the configurators, let's say in this way. We are interested to work on the compliance, generally speaking, with the compliance to the reference architecture model 4.0, and one important aspect is to improve and improve the data up according to the new specification. And thanks to this activity, we will be able also to integrate the App Store. And last but not least, we are always interested to add new validation cases and new integration use cases in our roadmap, since in this way, starting from the real requirements, from the real life, we are able to improve and to add functionalities that can be really used and can be really useful for the users in several domains: manufacturing, energy, agri-food, and so on. Here I put some references. All the code is totally open source. You can find all the project and the sub-components in the engineering, research and development repository on GitHub, but you can find also the same same repositories under the IDSA GitHub repository, that is the IDS umbrella for the open source components. Now I leave the floor to Igor for the hands-on session. Please, Igor.
Okay, thank you, Gabriele. Let me just see. Probably someone will have to set me as a presenter. Show my screen. Okay, So just give me a sign if you can see my screen.
Yes, we can see.
Okay. Okay, so as Gabriele mentioned, the starting point for the True Connector is the Dockerized version, since that one would be, let's say, the most convenient and easiest way for someone who is planning to use our connector to start with. The idea is that at least for the starting point, you should just click here, either clone or download zip. And once when the download is completed and when you unpack the files, you should be able just to type the Docker Compose up and to start playing with the connector. While we are waiting for the zip to download, we have also tried to put all the necessary information for the users of the True Connector on how to start. There are, let's say, some descriptions here and a table of content with, let's say, separated in the several chapters, and that the user can, let's say, start reading with this one, and then once when the reading is done, he should be able to, let's say, know what are the possibilities, what are the options of the True Connector, and also to play a bit with that thing that Gabriele mentioned, that with configuring and setting up and changing the default configuration. Here we will see that just a second, here at the top, the idea is that connector comes as a default configuration. So basically, there is a secure communication with self-signed certificate. Multi-part form is the format for the message exchange. DAPS interaction is disabled. Usage control is disabled. Interaction with the clearinghouse is disabled, and there are, let's say, some under quote security related features that are also disabled that can, let's say, be turned on let's say, in a real life scenario. But since, for example, for the DAPS interaction, you will require to receive the certificates from identity provider, and that one, let's say, can take some time to obtain. And we were thinking that at least for the starting point, that it would be, let's say, easier for users to have, let's say, all those features turned off that might cause some, let's say, issues and problems, and probably, let's say, some frustrations for the users, so that this is, let's say, the minimum setup that you can start to play with to start it up. And then once when you have, let's say, verified that you can configure the True Connector and that you can exchange the messages, then you can start by changing the modification. So like I said, to maybe enable host name validation, or let's say to change the format from the multi-part form to the mixed or the HTTP header, maybe to switch to the WebSocket, or add also the DAPS validation to enable the clearinghouse, enable usage control. So like I said, the idea was to, let's say, start simple, start quick, and then once you have verified that everything is working correctly, then you are, let's say, feel free to play with the connector and then to check to see if to turn on some, let's say, advanced features. I encourage you, if you still did not go through this README, we are trying to make this one up to date, and when we receive some feedback saying with some questions that are, let's say, the users had issues with starting with the connector, or let's say using our connector, we are trying to put those solutions, so let's say answers to those questions into the README. So we are trying to keep this one up to date. Why is this one taking a little bit longer is that we have also added here in the document folder, we have added here in the tutorial. Also, you can find the videos, basically the same thing that I will do now. So this one has been downloaded into the True Connector main. So if we just, let's say, upload this, extract this one, go into the True Connector main, open the terminal, Docker Compose up. Docker Compose up. Okay. So I have already downloaded the images, and if you are, let's say, running this one on your local machine, probably it will take some time for you to download the images, but also if you are using a Linux environment, maybe Docker Compose will have to be sudoed or something, but it depends on your, let's say, operating environment. So once when this is, let's say, started up, here inside the zip, you will find the two Postman related files. One of them is the Postman collection for interacting with the true connector, and this is that file, and the other one is the environment variables that are, let's say, configured to use the Dockerized environment. So I would either suggest you to open the Postman and to import those files. So just import both Postman collection. I will replace this one, and also to import the environment variable file here, also replace. So you will get the Postman collection like this. So this one is, let's say, separated into three different sections. One is related with the self-description API. That one is will, let's say, manage the self-description document of the connector. So you will have the options to change the self-description by adding the specific components of the self-description component. The second one is the one that we are going to cover today, is basically the exchanging data between the two connectors. And the third one is the interaction with the metadata broker. For the first one, you can find this dedicated markdown file in the repo. So yeah, feel free to take a look at that one also. And yeah, basically once when everything is up and running, just a second, let me change the environment here. So through connector environment, and if you open the artifact request message, you will see that we need to provide the authorization header for the provider connector, and here is how the body looks like. Just to check, okay, this one is, I think, still up and running. This one is the endpoint of the consumer data app, the proxy endpoint. This is the, let's say, the convenient endpoint that we have created that will hide all the information that are, let's say, IDS related, that user does not have to, let's say, create the proper message for the interaction. And yeah, basically this one, if we inspect the environment variables here, just a second, I have to move this. So okay, so basically you will see that the multi-parties form forward to is the URL of the provider connector. The self-description is used for, let's say, for the other ones, and also the metadata broker. This contract artifact and transfer artifact will be populated later during the other use cases. But for now, if this one is not provided, so if everything is started up correctly, we should see the logs being exchanged from the data app, consumer, ACC consumer, provider, and basically we should receive we're seeing that DAPS is not configured, clearinghouse not configured, so this one should return us some default payload that we have added that can be used, let's say, to verify that interaction is working correctly. So yeah, basically this, if you receive this JSON as a John Doe with some, let's say, address, checksum, and date of birth, then you can verify that indeed you were able to start the true connector just by simply downloading the zip and executing Docker Compose, and yeah, basically that's it. And so you can verify that it is working correctly, and then you can, let's say, proceed with doing all kinds of modifications and changes. And for example, we can do this, do one update to add the usage control, sorry, DAPS interaction, and to do the usage control for this one. So let's say two things in one go. First thing is that we need to copy the certificate files for the identity provider into the ECC cert folder. That information can be found in that README. So I have here some, let's say, some certificates. So just to copy them there. And in order to do that, we need to do the modifications in the M file. Basically, what we did, we had in mind with the configuration of the true connector is that most convenient properties that needs to be changed are located in the N file. So if you open that file, you will see, for example, the trustor here. That one is also needed for the DAPS interaction and also for the hostname validation. And I will just provide the information for the DAPS key store, alias, and password for the provider, and also the things for the consumer. That's one thing. For example, we can also enable here to fetch token on the connector startup through. So just let's say to basically to pre-fetch the token, and also you can also enable the feature for the connector to cache the token, so that you do not always have to make requests to the identity provider to get the new token. So token will be cached, and basically before using the token itself, the connector will check if token is about to expire, and if that is the case, then it will, let's say, fetch the new token and update the cached one, so with new expiry time. So basically it will fetch the new token for you. So we can also enable this one to true. That's one thing. And the other one is that you will have to change the property files. Basically, this one is something like advanced configuration for the true connector. So this should be done, let's say, with caution, and if you, let's say, know what you are doing. So that's just to check. So this property is enabled DAPS interaction should be also set to true. And here you can find for example, the DAPS URL. So we are currently using the ISAC version 2 identity provider of the Fraunhofer. That's one. And we should also change usage control, just let's say to speed things a bit. So basically to change that one is for the consumer, and also the same change should be done for the provider. So change this one to true, save, and for example, while we are here at the usage control, you see that this property here, usage control version, is set to Platoon, and this will tell that we will use the Platoon usage control, the one that Gabriele mentioned. And you will also find the description here, so you can set it to my data or Platoon, and then basically to change the usage control to be the my data one, which is, let's say, I think free for the non-commercial usage, but let's say for the real life you will have to pay for that one. And also there are information present in the README, since this one is a little bit complex little more complicated to change. It's not just by changing the property, you will also have to do things in the Docker Compose YAML file, but more information can be found in the README. So when we have changed this one, we will start the Docker again. When this is up and running, we should see in the logs that both consumer and provider execution core containers are now fetching the token and validating the received token from the identity provider. And basically, when sending the request, they will enrich the original message with the fetch token. So we can now use also the access management functionality of the true connector.
Igor, just to complement, if I can, of course, this is the Docker Compose that we are executing and we are sharing with you is for demo purpose. So in the real life, you will have or consumer and provider will be on two different sides, no? Since the exchange is a B2B exchange.
Yeah.
But of course, for demo purposes.
Yeah, basically this is, let's say, everything is running, let's say, locally in a local host, so no two physically separated machines for this one. So just, let's say, for the simplicity. Yeah, now since we have enabled the usage control, basically this means that every resource that you are requesting, even this John Doe, should not be permitted or should not be allowed unless explicitly granted. And in order to do that, we would have to perform the contract negotiation. So basically that consumer and provider connectors exchange the contracts under which now you see the logs for the token. So now if we try the same thing here, we should get some slightly different answer saying rejection message, or let's say not authorized, because, and I think it will also say in the usage control, so reaching the message with the token. Previously it was having some, let's say, dummy value. So you see here policy proceeding with usage control, no valid contracts found. So basically it says that there is a, basically the policy enforcement said there is no valid agreement inside the usage control app that will allow the consuming of this policy or this artifact. And yeah, you will see here, let's say, not authorized. And in order to do that, we will have to perform the contract negotiation. You can basically execute one request at a time, or maybe just to speed things a bit, just to click on the folder itself and click on run. And yeah, I will just put here a little bit delay for 1 second, and basically this one will send description request message with, again, to fetch the wholesale description, then to get the resource, the offered resource that is actually that John Doe. Then basically to send the contract request message, okay, give me a contract under which this resource is being offered. And just, let's say, for the simplicity, we will not do this negotiation that can I get that one, let's say, for some smaller amount, or let's say for some basically to do the negotiation. So, but just, let's say, for the simplicity, we will just, let's say, accept the initial offer for that resource, and then the consumer will send the contract agreement message, and the provider will reply with like to say like okay. And in basically in the response process, in the response flow of this request, the policies will be uploaded on both consumer and provider usage control app. And now when we send the artifact request message again, basically those fields, 2 fields will be populated. I will just click here run, and just to let that run. And yeah, basically the initial artifact request message here will now contain properly set values for the artifact ID, and also the ID of the agreement that has been exchanged. So basically this will now be extended with, okay, I want that John Doe artifact, and this is the agreement under which I'm requesting that data from the provider. And if everything is set correct, okay, so once when we send the request here, we should get also the basic data app consumer. So now we see that we have received basically the same response like before. So now those requests have the set for the test part, and basically they are populating the variables that will be used in a subsequent request. So this will, let's say, conclude the first part of the demo. Do we have maybe some questions here, or we would save them for the later? Probably, since for the second part I would have to start the test bed setup and the true connector. and for some reason it's taking a little bit slower here. So the idea is that we have the testbed setup. As a one Dockerized thing. I have just, let's say, preset everything here, so made the modifications that are needed for the true connector that are described here in the dots in the test bed. So here you have the README for the test bed that basically start with download the test bed project and then proceed with modifications that are needed for the true connector in order to be compliant with the setup of the test bed, basically to generate the certificate that will be used for the DApps, and yeah, to change the properties that we did before, verify that the message exchange format is form, enable DApps, and yeah, change the URL of the identity provider, because that one will use the one that is provided with the Docker Compose that I'm currently running. And yeah, basically all the things do the Docker networking, because yeah, now you have to link the networks of the execution core containers with the network that is defined in the testbed the Docker Compose file, in order for the execution core container to be able to see the maiden host name. And yeah, if you want to, let's say, do the more thing, yeah, feel free to take a look at this one. And basically I did all of this, and yeah, we will proceed with starting the also with the starting of the okay, just it will start. Okay, so for this one to work, it will be necessary for the testbed environment to be properly configured, and this one comes with several requests, and basically it's described in the testbed repo. So for that one, I will have to execute several requests here to change just to no environment. So basically to populate some test data in the testbed provider connector. Hoping that this one is started. Okay, so go one by one. Basically what I'm doing here is that I'm creating that John Doe, but not the John Doe, but the actual some data that are used in the test bed, creating the offer and offered resource and other stuff. So and for this one, you will find the already configured Postman request in the testbed folder that I showed in the True Connector repo, and we will use that Postman collection to perform contract negotiation with the data space connector and to fetch the data that I'm currently creating here. That Postman collection can be found in the testbed project. Sorry, in the testbed folder. Basically, this is the data space communication Postman collection, and just to verify it, okay, this one is still up and running. I have uploaded this collection here in the Postman. Let me just close all tabs, and just to make it simple, basically this one will do the same thing fire several description request message to narrow the search of the resource that we want to fetch, perform the contract request message, accept the offer that data space connector provides, and send the agreement that we will that we agree on the terms and conditions for that resource, and then fetch the artifact itself. So just to check if, okay, we have fetched the token from the maiden dApps, and if we click run here, also to put 1 second, just to give, let's say, some time, hoping that this one will work correctly. Also, we see the logs being changed, both from the both connectors, so those two, fetching the cell description, sending the request. Okay, okay, so we were able to, let's say, get all the requests, and we should, let me just check to see. Yeah, sometime for some reason we are still investigating why this one happens. Basically, the last request for some reason keeps hanging, and the postman does not receive the response. So I will just try to send the artifact request, because I saw that the agreement has been okay. The recipient error. No environment. Let me just check for to execute this one again. Okay. It's just a second. Just to stop run. So contract agreement, environment variable no. Send DC proxy. Okay. This was not supposed to happen. Could not process request. Didn't speak coding, not artifact. Okay. Process request. Okay, let me then just go to try one by one. Okay. Contract agreement. Okay, 200. Okay. And if we send this one, we should get some base 64 encoded thing. So this one is the one that data space connector provides. The data, it's some weather information thing that they have added. See, we can also use the base 64 decode, and if we paste it here and the code, this one is some, let's say, some JSON data. So this one also confirms that we were able to perform the contract negotiation manually, but at the end that one worked, and we were able to, let's say, consume the data with the contract agreement that we did in the negotiation phase. So this one would conclude the both demo presentations that were planned for this session.
Thank you,
Okay.
Igor. We received some questions in the meantime. I can find the chat what I replied, but if you can spend, Igor, a few words regarding the policies that we currently support, since we said that we have two different frameworks, no? Data and Platoon, and I share the link, with with the documentation we produced, with the examples and the kind of rules that currently we support. But could you complement a bit more?
Yeah, for this one, currently we are supporting a time-based interval. So basically start date and end date, the location-based interval. So the connector should be located in some country, and also the purpose-based interval with, let's say, some limitations that currently the purpose should be, under quotes, let's say, hard-coded in the decision-making process. So that those are, let's say, the three policies that are supported for the platoon one. And for the my data, we also support modified policies. So basically, if the payload is a JSON format, you can provide the JSON XPath rule, and basically to also say that with this JSON path, you should rechange the value to some, let's say, mask thing. So for example, in our case with the John Doe, I think it's birthday or something like that field. So you can define the policy, okay, mask birthday to be, instead of to not be visible, but let's say some XXX or star star star. So basically to replace the those things that might be, let's say, used for the GDPR policy if those are required. And you can also use the combinations of those policies. And if you use combinations, then it is applied and policy. So basically all the policies, all the rules that are evaluated must be evaluated as true, so that overall policy is evaluated as true.
Okay, thank you, Igor, for the explanation. In the presentation, we put the link with the videos that Igor showed us before, and represent exactly the demo that Igor today performed. If you want to reply, and with the support of some videos, we have a few minutes for additional questions. If you have in the presentation that colleagues from IDSA will share, you can find also our contacts. Anil?
Well, thank you for the wonderful presentation, and maybe here for the remaining few minutes we can have some more questions from the audience. So I will just go ahead and unmute everyone, and we already have a raised hand from Angel Ramirez Fernandez. Please, you can unmute yourself and go ahead.
Hi, my name is Angel. I would like to know, according to the graphical user interfaces, do you have any idea about when will it start?
Yeah, well,
the development, I think so.
Yeah, I don't know. We are in phase 2. We have just started the design of this graphical interface, and for this particular topic, we are in contact with the colleagues from the OneNet project, since they worked on it, on the fireware extension, but we want to analyze what are the requirements from the field, from the users. And yeah, after this, we will complete the design phase. We can establish a tangible plan with specific deadlines. And of course, our idea is to publish information also regarding the roadmap on our repository. So just have a look to our repository to see when we update the roadmap accordingly to not only our internal plan, but also with the request that we received from the projects and from the consumers. That is really important for us to be driven by users and not by the
yes,
paper.
I think so to have a graphical user interface is a good idea, yeah, because a lot of consumers are waiting for it. There are a graphical user interface in the IDS community nowadays. Have you got any idea to use that?
To be quite honest, no.
No. Therefore, you are thinking to develop the new graphical user interface by your own.
Yeah. But it really depends of the requirements that we will consider during the design phase.
No.
Still work in progress. So no, I cannot anticipate, since really we want to understand well requirements and needs for the users. Since our point of view is not so valid when we are talking about graphical interface, no? Since we have to address and reach a wide audience, and who is not, for example, familiar with this concept, with the connector, with the, like we are doing, no? Also, and the importance of the minimum valuable data space go in this direction, since okay, not all, in order to lower the barriers for the adoption of the data space, for the usage of, for example, our connector, but also other connectors, it is crucial to catch all requirements and all needs from the wide audience. So yeah, to be quite honest,
explanation was very appreciated for me, and I'm looking for watching something like that in the future releases. Okay.
Thank you for your questions.
Thank you for your.
Well, as we are out of time, so I just want to thank you really on behalf of IDSA for the wonderful presentation and for the great questions raised by the community. So just to ensure the community that we will be sharing your questions with our presenters and also the presentation with you. So we have all the email addresses, and we will ensure that this will be done today. And thank you very much again for your attendance and the great presentation, and we are really looking forward to the next steps of the project.
Thank you. Thank you all. Bye.
Thank you. Bye-bye.
Thank you.
Thank you.